So we were looking at a definition. We say that if B, defined by vectors b sub 1 through b sub n as our bases, then the coordinates of vector x relative to the basis are weights c sub 1 through c sub n, such that vector x is equal to the linear combination of these vectors c sub 1 times vector b sub 1 plus all the way to c sub n times vector b sub n. And the coordinates of vector x relative to the basis is denoted as vector x sub b, and this is equal to the column vector containing the weights. So we have the column vector of those weights c sub 1 through c sub n. And so although this notation is new, we've already been working with vectors like this. So here we're looking at a cute little warm-up example to demonstrate to us how we've already been working with vectors of this notation. So here we're considering the vector u defined as a sub 1 times vector e sub 1 plus a sub 2 times vector e sub 2 plus a sub 3 times vector e sub 3. And we're asked to find the coordinates of vector u relative to the basis b. And so looking at this given vector here, we realize, well, we can recall that these three vectors, e sub 1, e sub 2, and e sub 3, are just the elementary vectors in R3. Our good old friends, those elementary vectors in 3 dimensions. So the first thing we need to do is identify the basis here. So we can say that the standard basis, and we usually say the standard basis E, when we're working with our elementary vectors, is the set of these 3 elementary vectors, e sub 1. So here we can say that our standard basis E is the set of vectors e sub 1, e sub 2, e sub 3. Now, since these are just the elementary vectors, or since our basis consists of the elementary vectors, we can rewrite our vector u as follows. We can say that vector u, which here is defined as a sub 1 times vector e1 plus a sub 2 times vector e sub 2 plus scalar a sub 3 times vector e sub 3. And again, because these are just those elementary vectors, those unit vectors, we can rewrite this as the column vector a sub 1, a sub 2, a sub 3. And so, giving us a little bit more room, we can say, therefore, the coordinates of vector u relative to the standard basis E so we have vector E sub u. So you could either put sub E or sub B. It is the same here. And it's the column vector of these 3 coefficients. That should be a sub 1, a sub 2, a sub 3. So in boxing up our beautiful final answer here, we realize that the coordinates of a vector relative to the basis is simply a vector of the coefficients. So we can say a vector of coefficients or weights or scalars, however you want to refer to it. So it's a vector of coefficients or weights of the vector that you're considering. And that's it.